Welcome to Interchapter E. In Interchapter E, we're going to talk more about how to name compounds with suffix-changing functional groups. Specifically, in this chapter, we're going to talk about how to name alcohols, amines, aldehydes, and ketones. First, we're going to start off by talking about alcohols and amines. You've seen this slide before, and we're going to refer back to it as we go through how to name alcohols and amines. The first thing we have to do is talk about the suffix. For alcohols, the suffix is ol, O-L. For amines, this is an easy one, the suffix is amine. Remember that our parent chain is going to have to contain our alcohol or our amine. The prefix is determined by the number of carbons in that parent chain, and then we combine those to give the root name. Then you'll go through and name the substituents just as we did before in previous nomenclature chapters. You are going to number the parent chain so that in this case the alcohol or amine has the lowest possible number, and then you'll give each substituent a number in front of its name separated by a hyphen, just as we've done before, order the substituents alphabetically, and then combine everything and add the root name to the end. So the key steps that are going to change with alcohols and amines are determining the suffix, because the suffix is going to be different, determining the parent chain, because the parent chain must contain the alcohol or the amine, regardless of the length of other possible parent chains, and we are going to have to number that parent chain so that the alcohol or amine has the lowest possible number. Before we get into some examples, let's quickly identify the differences between a primary, secondary, and tertiary alcohol. A primary alcohol is attached to a primary carbon, or a carbon that's only attached to one other carbon. The red carbon I've circled here is attached to one other carbon. A secondary alcohol is attached to a carbon that is attached to two carbons. 1, 2. And the tertiary alcohol over here is attached to 3 carbons. 1, 2, 3. Obviously, our alcohol can't be attached to more than one group, so we have to look at the carbon that it's attached to. Now let's look at our first nomenclature example. We have 1, 2, 3, 4, 5, 6 carbons in our parent chain. That means because we have an alcohol that we're going to have a hexanol. And the alcohol for the hexanol is at position 3. We want a number from the right, 1, 2, 3, because if we number from the left, we won't get the alcohol until 1, 2, 3, 4. So this is a 3-hexanol. That means we have a methyl group at carbon 5. Don't forget, you can also put the 3 in front of the ol if you want to use that method to indicate where the alcohol is. Here's our next example. In this case, it's a little bit tricky to identify the parent chain. You have to make sure that the parent chain contains the alcohol. So this is our parent chain here. That gives us a propanol. That means that we have a 1-propanol because our alcohol is attached to carbon 1. At carbon 2, we have a cyclopentyl group. So that would give us 2-cyclopentyl, 1-propanol. We can also put the 1 in front of the ol as shown here. Okay, here we have some more examples on naming alcohols. You can see that we have methanol with 1 carbon, ethanol with 2, 1-propanol or propan-1-ol, 2-propanol, and 2-methyl-2-propanol. We also have more examples of primary alcohols. You can see that ethanol and 1-propanol are primary alcohols because the alcohol species is connected to a primary alcohol that I've circled in pink there. 2-propanol is a secondary alcohol because that green carbon there is secondary. It's connected to 2 other carbons. And 2-methyl-2-propanol is a tertiary alcohol because that red carbon there is connected to 3 carbons. These alcohols have common names, which are in the parentheses here. You don't have to know these, but they're very useful. For example, 2-propanol has a common name of rubbing alcohol or isopropyl alcohol. And so it's kind of useful to know, if you're buying that in the store, what the actual structure is. Let's look at another example. Here we have cyclohexanol. Notice that for cyclohexanol, we don't have to put the 1 anywhere. That's because the alcohol is the suffix changing functional group, and so it's presumed that the alcohol is on position 1, so we don't actually have to put the 1 in there. Here are a couple other examples. An alcohol that's attached specifically to a benzene ring is known as a phenol. For now, you don't have to know phenol, but it's good to keep in mind that an alcohol attached to a benzene ring has its own special name to it. This is a good one to go over. We have phenylmethanol here. This parent chain is 1 carbon. That's where we get the methanol from. We don't have to put a number, though, for either the alcohol or the benzene ring, the phenyl group, because there's only 1 carbon there. So you don't have to say 1 phenyl, 1 methanol, right? Because there's only 1 carbon. So we just say phenylmethanol. Now let's start getting into amines. Now for alcohols, our tertiary alcohols were attached to a carbon that is tertiary. Whereas with amines, a tertiary amine is attached to 3 carbons. This is because nitrogen can have more than 1 bond. A primary amine is shown over here, and that's because that nitrogen is only attached to 1 carbon. Let's do an example of a secondary amine. So this nitrogen here is attached to 2 carbons. So this would be a good example of a secondary amine. Let's look at some examples of naming amines. The suffix for amines is amine, so that's pretty easy. And remember that amines are important suffix changing functional groups, so we need to give them priority. In this example here, our parent chain is going to be in pink there. That means our amine is going to be at carbon 1. So we're going to call this 1-propanamine. We have 2 methyl groups here now that we have to account for. Those are both attached to the nitrogen, so we're going to use an N to indicate that. There's also 2 of them, so this is going to be a dimethyl. If we put this all together, it's going to be N, N, 1 for each methyl group, dimethyl 1-propanamine. You can also put the 1 between the propan and the amine if you would like. Here's another example. In this case, our parent chain is the cyclohexane, so it's going to be a cyclohexane amine. And our nitrogen is connected to a methyl group and an ethyl group. Ethyl comes before methyl alphabetically, so this is going to be an N-ethyl, N-methyl. If we put it all together, we have N-ethyl, N-methyl cyclohexanamine. Here's a little bit more on naming of amines. We have a couple more examples of primary amines. That means that we have 2 hydrogens attached to the nitrogen and 1 carbon group. So we have ethanamine here and 2-butanamine. Those are both other examples of primary amines. We also have more examples of secondary amines. In the case of N-methylmethanamine, 1 carbon becomes the parent chain, so that's the methane, and the other methane is attached to the nitrogen, so that's the N-methyl part. Another good example here is N-ethyl cyclohexanamine, which has the hexane as the parent chain and the ethyl group attached to the nitrogen. Over here with trimethylamine, 1 carbon becomes the parent chain and the other two methyl groups become the NN dimethyl. It's also important to note that if you have a nitrogen attached to a benzene ring, it's referred to as an aniline. And our last example here has a methane amine with a phenyl group on it. Again, everything in parentheses here, those are all your common names. You don't have to know those. They're just helpful sometimes, especially in the lab.